Hello, this is Sandy Nadelson, and I'm here to talk about quantitative measurement and sampling. The learning objectives for this lecture are to identify the types of probability and non-probability sampling strategies, discuss the advantages and disadvantages of each, and discuss the factors that influence sample size. Identify the types of data collection methods, list the advantages and disadvantages of each type, and then evaluate sampling and data collection methods according to research design. So lots to cover today. Sampling. Sampling, as you know from that assignment a couple of weeks ago, has to do with finding the people or things in your study. Most research that nurses do relate to people, but it might also be animals or objects or events. For the majority of us, we're going to be looking at people and say something like, what are the stages of the sick roll in patients with stroke? So the population would be anyone who's had a stroke, and then the sample would be the group in which we collect to be in the study. So hopefully, and with quantitative, anyone in the population that relates to that would be a possibility, but then our sample is the actual ones that we include. To select representative units of the population for study is what we want, and sometimes that's unfeasible though. You just can't go to any state and any hospital and do the research, so sometimes you have to make some limits and say, I'm going to look at people who had strokes in a particular town. And I think usually in research studies, they won't, in the writing up, they won't say exactly what city that they're from, but they might say a mid-sized northwestern United States hospital or town, city, or whatever. And a lot of times you can look at where the person's from then and figure out, oh, okay, they're talking about University of Washington, because that would make sense there. But there is obviously limits to what people can do. In terms of who's in the study and who's not, the researcher decides who's going to be in it. Population might be, anyone over the age of 21, anyone at stage 0 to 2 breast cancer that's had chemo or is having chemo or radiation. And they can decide chemo and radiation, chemo or radiation, or then maybe the control group would have no radiation or chemo. But that's, once again, it's going to be hard to find those people, so you have to think about that. Exclusion criteria: if the person had a psychiatric condition or metastatic disease, that might be something that the researcher decides on at the beginning, and it's best to be very specific as a researcher on who they are going to be including and put that out front so there's no questions later. And in the research reports too, that information should also be provided so people will have a better sense of the generalizability of the results. So you'll hear people talk about different types of sampling. The one that's considered the best is called probability sampling. And then in terms of this one, each element has the same probability of being included in the sampling, and that is equal to being a random sampling. So it's more likely to result in a representative sample or representative of the population. So non-probability, to help I define that, is that the researcher is unable to estimate the probability that each element of the population will be included. The total population is unknown or too difficult to identify. So, for example, if a researcher wanted to know about women's understanding of the influence of copper on their health, and they went to a grocery store in a town and interviewed everyone that came into the grocery store on a particular day, that would be, not really a random sample. It was just whoever got to the grocery store that day. If it was the beginning of the month, if you live in a town that has a lot of people who are on state aid, and the beginning of the month when the money comes out, it could be a really, really different group of people than what you might find midway or later on in the month. So once again, it's hard to estimate. Sometimes it's impossible. Sometimes you just have to go with what you got. And And that's a consideration a researcher has. Can we get a probability, a random sampling, or not? Do we need to? If they don't, or even if they do, they should once again include that in the report. In terms of probability sampling, the random sampling, there are two different types. You hear simple random and stratified random. Simple random means the researcher might have a list of all the people in a population. You utilize a random selection method, maybe ask the computer to pull names out randomly. There's a table of random numbers. You can go on the internet and find that, or just really random, draw names from a hat. Not very scientific, but it still works. It's still considered a simple random. The advantage is that you feel more like your sample is representative. The disadvantage is sometimes it's impossible to have a list of the people, and it takes time, and it can be a problem. Stratified random sampling is an interesting process, and it divides people into subgroups, or what's called strata, for stratification. And then you kind of make an estimate of what type of people, groups of people are within that. For example, if one wanted to do research on job satisfaction for RNs, and they wanted to know, is there are we going to get a real random sample that is representative of the whole group? Maybe let's think about the state of Nevada, and how many percentage are ADN grads? How many are bachelor's grads? How many people have advanced degrees? And they might say, all right, well, we want to try to get a sample that is similar to those numbers of people. So we're going to ask the state board for, all the names of people who have ADNs as their highest level of education. And then we'll pull out from the ADNs group randomly a certain percentage of that. So maybe we say that 33% of the state is made up of ADNs. I think that's probably more like 50%. And then, so let's say 50%, say half of the people from the study are going to come from that ADN list. So then they have the bachelor's list. Say 35% are bachelors, and so they pull out randomly from that group 35% of the total study. So let's say there's going to be 100 people in the study, so 35 people. And then the last 15 is advanced degrees. So they pick out 15 names, 15% from those advanced degrees. Then all those people get sent out the surveys, and they're included in the study. Sometimes, once again, it's hard to find, know exactly how much is out there. RN's a little easier than other things, but it obviously makes it a lot more complex. Sometimes we can't do probability sampling. We might try convenience sampling or quota or purposive. And another one strategically is matching or snowballing. Talk about that. In terms of convenience sample, it's the subjects are convenient, and once again, it might just be all of the people that had surgery at this one particular hospital over, a 20-month period. Snowballing is one type of convenient sampling, and that is usually snowballing, for example, let's talk about people who maybe had appendicitis and had their appendix removed. You find one person with appendicitis, and once you recovered, everyone in the world goes, oh, my cousin has, had his appendix out, and then you meet the cousin, blah, blah, blah. So you get this whole group of people, and so you might say, they ask one person who had their appendix out, can you tell me someone else who has had their appendix out? So they might pass that information on, and so the group enlarges. An idea too, like with foster families, you might want to look at the knowledge of healthcare of foster parents taking care of kids with medical issues. And so you go to a meeting, a foster families support meeting, and you meet a couple of people, and then you go, hey, do you know any other people that might be interested in participating? And they go, oh yeah, I've got a friend who lives over here, here's their number, and you contact them. So it's easier in terms of you don't have to worry about, oh, I've got to have this big group and randomize, but there is a bias for selection because you're getting people who other people know, and that might not be representative of everyone. Quota sampling, it can be considered non-probability, and select the numbers of each strata based on the the percentage, and once again, this is like talking about that, but you can also use matched pairs with this. So a little bit different. It's considered non-probability, although you could, if you random select within each group, do be considered more of a strata. Anyway, advantages, there's more control, a little less, or a little more convenience in terms of you'll have some idea of who you're getting or whatever, and that there's no way to, once again, assess your bias. So quota sampling is helpful, once again, taking the proportion of quota, but it is not quite as strong as a random sampling, although I think there's some real advantage of that. Doing research on kids in schools, you might want to, know their knowledge of, how much activity they need, and you want to have a sample of 100. It's really nice to go, okay, well, we have, the same amount of kids in 1 to 6th grade, so we need to have maybe, what would that be, about less than 20, about 18 from each class. And that way you don't have a pile of 1st graders and not a pile of 6th graders. It's a little more, I think, even. Purposive sampling, a researcher looks at certain criteria, mothers of liver transplants, and they might then go to select from maybe a group of support people, something like that. You could also maybe do a focus group or find some people who are willing through through a support group to come in. You can find lots of information on that. It's certainly an unusual group. It's not a random selection, but sometimes that's what you got and that's what you go for. So that's that one. Issues of sampling size, once again, with quantitative research. The more you can get, the better. In terms of surveys, depending on what you do, 20% of your response is good in terms in terms of who responds. If you mail out 200 surveys and you get 10 back, that's a problem. And that should be identified in the research write-up that only 10, less than 10%, 5% that would be responded. It shows that maybe the people who responded aren't homogeneous with the other groups. Other things you want to look in terms of sample size, usually unless you have about 30 to 40 people in a study, it's very hard to show any type of difference statistically. So you can get 30 people in a study, that's great. 40 people's better. It depends, once again, how many variables and how much is going on with that. But those are some general rules. If I see a research study and they've only used like 12 people, I got to tell myself, you know what, I'm not sure about this. It would be hard to believe that there could be statistical significance with only 12 people. And if it was, it must have been a real strong one, because it's pretty hard to do. All right, looking at measures. For measures, as you know, we can have both objective and non-objective information. Objective might be a blood pressure or a lab value, something like that. Systematic might be, how is it collected? Is it collected in an organized way and a consistency between people? Operational definitions, we talked about this before. You would have an explanation if you're talking about research on people with high blood sugar. Well, what do you mean by high blood sugar? And so that might be an HbA1c of over 7. So that operationalizes what that means. And then another, you can also have instruments do it, like a cancer survivor scale that is well put together, and say, a particular score or something like that might be what you're looking at and what you want to identify. Data collection methods, physiological measures, observation measures, interviews, questionnaires, and records and databases like medical records are commonly used. In terms of physiology, you might look at nausea, might look at what the results are from a treadmill or a lab test, something like that. It's more precise and sensitive, but it can be expensive and sometimes very kind of almost unethical to get some information from patients. Other things can also influence, like, people being more nervous and their blood pressures might be going up when they're around people who have a medical background. Observations can be systematic, might look at kids' activities within a classroom, and a researcher might count how many times a child left their chair. That would be an observational method. And so they might be comparing kids with ADHD with those who don't have ADHD. Can have some great information. It can be reliable and considered a good research method. Once again, people need to be trained and know what they're doing. Also, it can be a problem if the kids or whoever is being watched knows they're being watched. Once again, talk about that Hawthorne effect. And there may be some ethical issues too. There have been research. There was a research study about some people who were looking at gay men's behavior in San Francisco, and these gay men did not realize they were being observed, and felt very uncomfortable about that once it was brought out. So concealment, whether they're telling what they're doing and why they're doing it and seen, can make a difference in terms of the response that they get. Interview questions, you'll hear about oral interviews. That can still happen in quantitative. Certainly happens a lot with qualitative. Can be paper and pencil questionnaires or online questionnaires, much more common now. Types of questions, once again, the closed scale or closed-ended, like a Likert scale. If you rate your comfort to being cared for by a male nurse, 1 being uncomfortable, 5 being comfortable. Those kind of things. Also multiple choice, things like which are the most important to you. True, false might be, do you believe that diet is important in your health? That kind of thing. Open-ended usually are more qualitative, and you will see studies that have both open and ended and closed questions, and you'll hear people talk about mixed method research, and that would have both the quantitative and qualitative, and those work really well together in my view. Interviews and questionnaires, the advantage is that you can get a lot of information with the questionnaires. Interviews take more time. Disadvantage is sometimes when you're doing a survey and someone's asking the questions, you may respond differently because you don't want people to feel badly. I was doing a survey the other day and was asking me about ethical decisions. And, I was answering honestly, but I thought to myself, if someone was asking me these questions, might I respond differently? It's very possible, and something to think about. Using the internet for self-report is a trend that's up, and there are issues. It still is considered research, and so informed consent and confidentiality still need to be considered, even if it's information that's widely available. In terms of data collection, you're using records. I look at medical records, might look at videotaping, might look at a variety of different things. Once again, privacy issues might be difficult to access. Hospitals may not give people information about it or access to different records for good reason. And sometimes we don't know how accurate the records are either, so that's another issue. Locating instruments, like I said, having instruments that are made are very helpful. I've actually used the Watson's Measuring Caring and Nursing. She's got a whole book on caring research surveys, and some of them have been researched and used a lot, and some of them haven't. So it's nice to use, I think, ones that have been used quite a bit. That adds to validity and reliability and security of those instruments, rather than making them up. I've seen some people make some up, and it's like, oh, really, that doesn't really get to the point. So that is it. I hope you've learned something and feel a little smarter and a little more ready to use research in your everyday life. Take care.